that even those who are generally working in Germany or even closer in Bangladesh has taken time to come to this talk. My talk today is about maximizing co-benefits between air quality management, greenhouse gas mitigation, and energy policy for Thailand. This is actually the idea and the motivation for this has been actively in my mind since a few years, and I could say that since the beginning of my career, I was really focusing on how can we combine the best of air quality policy with climate policy, and as we know that the main driver for this air quality and climate policies is based on the energy consumption of each country, especially in Thailand. We need to pay attention. So this is how the air quality in Thailand is currently. We have two problems specifically in our country when we, with regards to air pollution. We have the problem of ozone, and the ozone level is found to be higher than the standard at nearly all the stations, and we have the level of ozone critically high within 23 provinces. Another thing is that whether we consider the standard values of 1 hour or 8-hour values, we still have a very high concentration or higher than the standard. Bangkok is one of the most concerned, and the major source identified in Bangkok is absolutely traffic. Here, in terms of air quality, ozone is a concern, but ozone is also a climate forcer agent, and therefore we were trying to look at the historical profile, and what we observed between 1996 to 2012, or even now, we have the average increase year by year. Another problem in Bangkok and in Thailand is regarding air pollution is the concentration level of PM10. Bangkok, of course, suffered of severe particle problems, and if you have the survey 10 years ago and even now, it has been we observed that Bangkok's population declared that the first environmental concern for them is, of course, the question of particulate matter. And for this, since although we have a declination of the level observed in Bangkok since 2007, however, we still exceed the standards in many areas of Bangkok. Another issue that comes every year is the problem of haze due to biomass open burning in the northern region, and this doesn't concern only Thailand, but also the neighboring countries in the CLMV region. And in 2012, although the burning was not severe as this year because of the issue of drought, we observed already more than 950,000 patients affected by the haze pollution in the 8 mountain provinces. And these, of course, represent a cost. And different diseases that we observe runs from cardiovascular disease, respiratory disease, of course, and the inflammatory of eyes or skin. But we can have also long-range transport of haze due to biomass burning or peatland burning in the southern part of ASEAN, more specifically from Indonesia and Malaysia. And we regularly now observe peat haze within Tram, Phuket, Songkhla, Stung, Yala, Pattani, Narathiwat, and also up to Nakhon Si Thammarat, where actually here and this year, when we will analyze further the results of this year, we will observe that these can be also a serious problem because our peatland started to be burned as well. But this is not the only, Bangkok and Thailand are not the only place where air quality is worse. Where I used to live, in Paris, we suffered of this as well. And I think that it's because in Thailand we didn't have the measurements. We started only to have PM2.5 measurements, but in Paris nowadays we can observe up to 185 microgram per cubic meter for PM2.5, which is finer, and so these largely exceed the standards of impact on human health. How in other countries, especially in Europe, deals with these problems that we found also in Thailand. Here, actually, this is done at the level of European Commissions, and for this, the main question that drives to set policy and tools or framework to study these problems and set it to become from policy to laws is how to balance emission controls in the most cost-effective way. The tools that the European Commission has developed is called greenhouse gas air pollution interactions and synergies, or GAINS tools. These has actually integrate the social development and economic activities. Then we look at different sectors in the development to see how the emissions are, and look at the control of emissions, more specifically of 10 air pollutants and 6 greenhouse gases, the conventional greenhouse gases. Then we go for emission estimation and input these the obtained emissions into atmospheric dispersion model, as well as the cost of these emissions and the control of emissions, to see if we vary the emissions, how the effect would be on health, ecosystem, and climate impact indicators. From the output of the results, we will take this as policy target and look at the way if we can maximize, minimize the cost, minimize the emissions, and how we can optimize the results on air quality and climate impact indicators. With all this, we inject all the results into the emission control options, and we run the optimization to find out the best solution or the optimized solution by varying different scenarios. And the results, the outcome of this, of course, would support the national and the European Commission's emission ceilings. As illustration, here is just to show you that when you drive the climate and air pollution policy, you may save money on both sides, and this is a real synergistic effect or co-benefit. And these can have a co-benefit on health and air pollution control cost. Here the example is done with comparing business as usual for the national energy projection, different countries in the EU, and the better energy scenarios with climate measures. Here in 2020, we set the assumptions that we need to, the European Commission would reduce their emissions in carbon dioxide by 20% compared to the level in 1992. And what we observed is that with a better solution, better energy policy that include climate measures, we may save up to 20 billion euros per year. With this background and motivation, we have at GHG in my group developed a project that would lead Thailand into this kind of scheme, and the scheme of co-benefit between air pollution and climate policy with the control on energy consumption. And this has been, I would say, dream has been fulfilled when Toyota has put as initiative and selected GHG as the core key partners to develop Toyota's Clean Air for Asia project. And the objective of this project is to develop, of course, the emission inventory and projection for use in air quality models in order to assess the air quality and looking at how we will be able to reduce or mitigate or just simply bring ozone and haze at the level of out of pollution. And the second one is to investigate what are control technologies or strategies that we should apply for Thailand. Preliminary results that we observe is that with the emission inventory of the base year 2010, we observed that for CO2, which is the indicator of energy consumption, of course, the most important part is emitted by energy-related sectors such as industrial combustion, industrial or road transportation, and industrial combustion and so on. So, and for carbon, for other pollutants, for carbon monoxide, for example, these also would come mainly from road transportation, followed by industrial processes. For NOx and SO2 or PM, whether PM 2.5 or PM 10, we also found that the energy-related sectors are the most the top emitters. And the concern is that our particulate matter is accompanied by climate forcer agent like black carbon, and that will enhance the effect of global warming. We have then tried to do the short-term projection using the time series and progressing activities in all sectors, and we found that actually continuously CO2 and other air pollutants are still prevalently emitted from energy-related sectors. To be accurate and reliable, we need to test our or validate our emission inventory with other database and other estimations, and we found that actually by using the country-specific activity data and also country-specific control technology, implemented control technology and emission factors or emission conditions, we can improve the estimation of major pollutants like carbon monoxide and the particulate matter. For greenhouse gases, except for all gases, we have also an inventory consistent with other databases. However, for methane, for example, we observe a higher emissions compared to the international database, and the main reason is that in the national database there's underestimation of our agricultural sectors. Within this project, it is important to see that we didn't look at only at the emission by sector itself, but we are looking at the spatial distribution as well in order to identify hotspots for each pollutant, and so that we can apply policy, better policy, more specific policy region by region. As we can see here, for NOx, for example, the major contributor, the key process is actually from transport sector, and for PM10 here, we can identify that actually the PM10 would come from fuel wood burning especially in the region of lower northern part of the country and in the northeastern part of the country. For methane, the major source is paddy field or rice cultivation, and here this is consistent with the land use because we are looking at the area source, which is paddy field, and we observe here that actually we have the highest emitter is located in the northeastern region. When we look at more specifically, we have also nested down having the high resolution, especially for the region of BMR, because this is of high population and so dense exposure. We nested down from 12 kilometer by 12 kilometer grid to 1 kilometer by 1 kilometer, and we can observe that actually it is really inert because here NOx, which is the key emitter is the transport sector one. We noticed that actually the dense emission would be found inside Bangkok itself, and not so in the suburbs area or connecting provinces. We have attempted to see if we could at least do the projection, long-term projection, at least to cover the energy policy plan recently issued by Thailand called Thailand Integrated Energy Blueprint, which runs for the period of 2015 to 2036, and we have and the plan is called PDP 2015. Then we have here what we are doing is that here we have the actual data from PDP up to 2014, and if we continue with the projection obtained from IEA and used in a model under games following the World Energy Outlook 2011, we found that our emissions should go upward with and identified as GDP driver for around 7%. However, we have recently revised our GDP growth, and the current revision would be around between 3 to 4, and with this we then correlate with the try to see what difference we have with the PDP 2015, and here we observe that actually what we plan for the energy consumption in power sector in the PDP is actually lower than any other projections so far. But the effect of this decrease is not due to implementation of control policy of energy efficiency or energy renewable energy, but simply due to the revision of the GDP lower than what is planned earlier, 5 years earlier. And to complete our framework, in order to set up the policy, we actually also set up the framework for air quality modeling. And the air quality model that we use is named KNX, which include the dispersion module conditioned by the meteorological model, and the input in terms of meteorological model is WOLF. We are using WOLF to create the make files, and for emission inventory we use our emissions inventory. And this is what we can observe as ozone monthly concentration in 2010, and we can observe that actually we have ozone problem, ozone pollution problem by especially during the dry season, running from January to April, and starting again in December. For PM10, this is of the same observation, the same results. we have a high concentration of PM10 during the dry season as well. However, when we have to validate the results from simulation, we need also to look at, to compare, generally what we use is to compare the simulated to observation. And what we found is that in terms of ozone, our model framework seems to capture well. However, we still have slightly overestimated absolute level in all regions. And however, we have good performance on seasonal variation in all regions as well. For PM10, there's an underestimated of absolute level in all regions, except for the northern part of Thailand. But here we need to specify that actually we have not included the biomass burning sources. We didn't use our inventory for the biomass burning. The biomass burning has been has been integrated from an outside database. And however, we are quite happy to see that we have good performance on seasonal variation in all regions. And however, we still need to pay more attention on the eastern and northeastern Thailand, where observation seems to be much higher than the simulated models. As our objective is to look at the future and the effectiveness of the policy put in place, we tried also to look at how if the model that we put in place right now can also give a good difference between the current control strategies and the maximum control strategies that we can have. And here we have run the simulation for ozone for 2010. And if we go on with the same policy up to 2030, we can observe that the ozone hotspots would enlarge, and especially in the northern part of the country and around Bangkok, actually in the Gulf of Thailand. But if we apply the maximum feasible reduction technologies, MRF here, the ozone hotspot that we may have around Bangkok would disappear or would be reduced. The effect would be reduced. That is, that gives us confidence that we can, if we get the emission projection right, we would also have tools and framework to support policy formulations. With this, I would like to thank the audience, and this is the opportunity to present my research team as well. Dr. Kimberly, who is here, Dr. Ekapon, and Thadonpat, and Dr. Tao, the two letters are researchers under this specific project. Thank you for your attention.
Where does the ozone come from?
The ozone, as ozone is a secondary pollutants. It needs the ozone needs to be formed based on emissions of their orbit precursors, which are volatile compounds, but basically NOx and the solar radiation. So that's why the control ozone would not be applied directly to control ozone, but on the precursors, emitter sources.
Which transportation?
Transportation, the high emitter of NOx, we found that for NOx, this is due to transportation, but for VOC, we may have these from industrial process, like refineries.
Then I noticed one of your hotspots of ozone was actually Kaohsiung, which surprised me.
Because of the secondary formation characteristic of ozone, it transformed during the transport, and the dispersion from the source depends on the wind direction, right? If the major source is found, for example, here in Bangkok, the ozone itself would, according to the wind, can actually transport up to Khao
Excuse me.
Yeah.
How will you check the sensitivity of ozone to its precursor that is required for you to control
Yeah, thank you for your question. That is the way how we, this is the step we are ongoing to check the sensitivity. If we vary the VOC or especially NOx, we intend to first do the sensitivity test on the NOx emissions, how the ozone would be reduced. That is, the way how we do is just to set a scenario of 20 or 10% reduction, and what would come out. This is mainly important when we, for example, nowadays Thailand is intend to implement Euro 5 for transport sector, and I mean the Euro 5, the difference between Euro 5 and Euro 4 is mainly on NOx, and even the European countries car manufacturers are saying that it's really, really difficult to go up to Euro 5 emissions of NOx.
I actually have one question on your slide on the PM10 that you classify by region, and you found that the Northeast is quite sensitive. The PM10 by region. This is by year, right? That is that is what we have. At the back, almost finished. Yes, that's right. Because in the northeast, in the northern, right? So the standard error is quite huge. Do you have an idea on
the error here on the simulation is actually due to mainly due to the top up of emissions by the biomass burning emissions, and for especially for the from January to April. But after that, we are still wondering why we have such a difference and uncertainty in the outputs from the standard deviation here is obtained from when you compile all the days within the month. And this is the maximum and the minimum and the maximum that we observe. And therefore we are still checking these for the outcome.
So you think that the variation within the month is quite huge? I think someday you can have it very high.
And if we can find out the days on which we have the high spot, and if we eliminate those days, then I think this standard deviation can be
reduced. Yeah. But actually, I would say that to some extent, I personally prefer to let it like this in order to see that this is the only region where we have this kind of variation. And we don't know if this is due to the fact that we are at the border, common border with other countries. Because if we are sure of our division, inventory, and so on, we are obliged to integrate international database for outside, for Vietnam, for Laos, for Myanmar. And most of the flow will come from China and Vietnam as well.
The northern region will cover from Nakhon Sawan up to Chiang Rai, right?
Right.
So I mean that if there are some disturb from other countries like Myanmar or Laos or China or something like that, perhaps if you can identify it by provinces, then you see the disturbance outside.
When I talk that we can have a problem of border is that because in order to run the model, although our interest is on Thailand, however the domain should cover larger size and to include and to see these versions, all sources should be integrated, and we have a really high uncertainties up there. When we look at the domain of our interest, the northern part is included. I would say high, more area than in the south. So. That's why I mentioned about the boundary conditions, boundary effect that may come from uncertainties accumulate from outside.
Okay, is there any
Is it the pre-retirees or in Bangkok?
According to what I see here, I would really say that in Bangkok should be better.
Okay, good.
That's why I moved back from Paris. From Paris. And actually, one of the funny things is that where I used to live is really near this area.
Just ask another question. So the model, should it correlate the ozone to the pollution? Does it do that? I mean, do you see a direct link, or is that the whole idea that it is directly related to each other, or?
Yeah. the core of Chemex that we use as air quality modeling tool. The core of this model is actually linked the emissions and the dispersion, while in the model itself you have also the chemical transformation activities, and therefore it's by nature linked to each other. And that's how we can, for example, see the sensitivity effect that Nishik mentioned earlier, that when we reduce the precursor emissions, how the formation of ozone will react. And what we expect is, should we actually reduce NOx or should we reduce VOC?
And has that been done in other regions before, like to correlate like that? Or is that
We have some studies, especially by the team of Ajahn Sen on the control of VOC in industrial estates, mainly eastern seaboard of Thailand. But we have seen also that it is not only from controllable sources that ozone may form. We have also the transport of from knowledge.
My last one is that maybe you can elaborate more on the core benefit other than the money that used to control the emissions. What are the other core benefits that Thailand should have if this kind of study has been forward to government?
Yeah, actually, as I mentioned, what I would like to see when we get progress is these kind of image that we would like to submit to policymakers in Thailand. That if you combine climate and energy policy together, for example, what we have proposed in our INDC to the Paris Agreement, and to ratify the Paris Agreement, that is how we should, we would like our policy makers to understand that not only you will save the cost, you will spend more cost on control technology, but what you will get back in terms of health and in terms of course, in terms of life, but also in terms of energy efficiency, means energy saving, that would recompensate what you have to spend, and at the scale of Europe, which is up to 20 billion euro per year, that is not negligible.
So the community is saving the cost and also increase health, quality of life, and perhaps increase better environmental condition in the country, and even set up a higher standard. Higher standard is always good.
But it's true also that another message is that when you control climate agents, climate pollutant emissions, you may also control the air pollutant emissions. And this means for that much for industry sector or private sector, because if it goes together, that means less investment for them. And for the on-road transport sector for us, for example, the car that has a better energy efficiency, so low emission of lower emission of carbon dioxide may also emit less particulate matter or any carbon-related compound.
I would think that if you go down by sector, maybe more specific commodity like to reduce the emission of the fertilizer in agriculture that can help reduce the investment of the farm. And also something like that. I mean, if you would break down to each sector like the vision that you showed before, very much implementation. Okay, I think it's about time, and today we hear a very good talk, very interesting and intensive talk from Dr. Savitri. So thank you very much for your talk, and shall we show our appreciation